In this video, we are going to talk about some of our angle postulates and our first theorem. So our first one is our protractor postulate. Consider the ray OB and a point A on one side of OB. Every ray of the form OA can be paired one-to-one with a real number from 0 to 180. Notice on my picture here, I've got it on a protractor, and that is because what I'm actually doing is using that to find the measure of an angle. So our protractor postulate just allows us to find that measurement. So in this case, angle A the measure of angle A the measure of angle O, or you can say BOA, I'm going to do that, is equal to, now notice my red line passes through two different things. Kind of looks like it passes through 55 right there, and then here 125, depends on which direction you're reading it from. Because this one is obtuse, I am reading it from this way, so I'm reading the bottom one. So my measurement there is 125. Now, let's take a look down here and talk more about measuring. So our measurement of, let's go AOC. This time I can't say just angle O. By the way, this notation, I forgot we haven't talked about that notation yet. This notation, this means the measurement of angle AOC. Remember, the vertex is always in the center when you're naming your angle. Okay, so my measure of angle AOC, that's this one right here, is, again, my ray OC passes through 2 points. Because this one is acute, it's this bottom one. I'm following the bottom one, so 45 degrees. The measure of angle AOD, so I am looking at this angle, AOD. Hopefully you can see that that is obtuse, so I'm going to look at that top version right there, because that's the bigger, oh, sorry, nope, sorry, not true, bottom version, because that's the bigger number, so 115. And if we want, we could also do the measure of AOB. Notice that that one is a straight angle. In other words, it forms a straight line. Now, we can take this one step further and measure angles that don't have one of the rays on the 0 of the protractor. So the measure of an angle is the absolute value of the distance of the real numbers that the rays correspond with on the protractor. So if I wanted to measure angle COD, I would do the absolute value of the 115 minus the 45. And that's positive, so I can just subtract and get 70 degrees. And that is all there is to that. Our second postulate for angles is our angle addition postulate. So our angle addition postulate says if point B is on the interior of AOC, so B is inside, right there, here is AOC, then the measure of AOB plus the measure of BOC is equal to the measure of AOC. Notice that all this is the angle version of our segment addition postulate. So all we're saying here is that the two small parts of an angle add up to the big part. Pause if you need to. We're going to go to the next page. All right, we're going to look at our linear pair postulate first. So our linear pair postulate says that if two angles form a linear pair, then they are supplementary. So let's refresh our memory about what a linear pair is. It's two adjacent angles. Remember, that means that they share a side and a vertex that form a straight angle, which means forms a line or a measurement of 180. So this is an example of a linear pair. So if they form a linear pair, then they are supplementary. In other words, in this diagram here, the measure of angle 1 plus the measure of angle 2 is equal to 180. And that should make sense because they're forming a straight line. The measure of a straight line is 180. Finally, we're talking about our first theorem. We're going to prove this later. So a postulate we accept as true. A theorem we prove. So let's go back to page 1, and we have two definitions here. So a proof, first of all, is a convincing argument that uses deductive reasoning. It logically shows why a conjecture is true. You will have statements and reasons. The reasons can include definitions, properties, postulates, and theorems. A theorem is a conjecture or statement that you prove. So a postulate we accept to be true, no proof required. A theorem we actually prove. So the vertical angles theorem is going to be one of the first theorems that we prove, but right now we're just going to talk about it and use it. Pause here because I know this is a lot of writing. I'm going to go back to page 4. Okay, so our vertical angles theorem. Vertical angles are congruent. So again, let's refresh our memory on what vertical angles are. It's two angles whose sides are opposite rays. So our opposite rays are here and here. And so here I have two sets, the purple and the blue. So what our vertical angles theorem tells us is that angle 1 and angle 3 in this picture are congruent, and angle 2 and angle 4 in this diagram are congruent. Again, notation-wise, this is a measurement, so it's a number, so I use an equal sign. This is a figure, so I use a congruent sign. We're going to use these postulates and theorems in class the next time I see you to find measures of angles.